All right, hi guys, welcome back. So today we're going to finish up lesson 10.5, day 2. I am on page 307 in your notes, so you can jump over to that page with me. All right, so the first two questions, it says in exercises 1 and 2, find the number of ways you can arrange A, all of the numbers, and then B, 3 of the numbers in the given telephone number. All right, so you're given a telephone number and you're asked first to just find how many different ways can all those numbers be rearranged. So the first question you should be asking yourself, is this a combination or permutation type of problem? Is the order important? Okay, remember permutation order is important, combination order is not. Since these numbers represent a telephone number, if you rearrange the numbers, you're going to get a different telephone number, right? And if you call different telephone numbers, you call different people. So the order is important, all right? So for part A, it says, how many ways can you arrange all of the numbers? So how many numbers are there? 1, 2, 3, 4, 5, 6, 7. So we have 7 objects, right? Taken 7 at a time. So for permutations, this would be 7p7. Okay, so you can use your calculator. I'll show you on the calculator. If you hit math, go over to prob, go down to option 2 or just push 2. 7 objects taken 7 at a time. And you get 5,040. I think I'm reading that correctly. Yes, 5,040. All right, so that would be 5,040 different ways to rearrange the 7 numbers in that telephone. All right, now it says for part B, how many different ways can you arrange 3 of the numbers in the given telephone number? Okay, so the formula changes a little bit. It's still a permutation problem. We still have 7 objects, but we're taking 3. Okay, so if we could look at either of them using the fundamental counting principle, right? For this example, I'll show on the calculator, but if you're arranging the 7 numbers 3 at a time, what you're really doing, you have 3 spots for the 3 different numbers you're picking. You have 7 options for the first, then 6, then 5, okay, and you multiply those together. It'll result in the same answer that we're going to get. I'll get up on my calculator and then I'll show you. All right. And you get 210. Or as I said, if you just do 7 times 6 times 5, you still get the 210. Next problem, same idea, but we have a different number of digits in the telephone number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. So first it's 10 objects taken 10 at a time. So you'll plug that into your calculator. And when you do, you get 3,628,800. For the next one, still taking 3 of those digits out of the 10. Again, you could look at either of these using the fundamental counting principle. So I'll show the second one again. You have 10 options for the first digit of the telephone number, then 9 options, then 8 options. Okay, that's going to be the same thing as 10 permutation taken 3 at a time, which will give you 720. Okay. Let me just erase and get problem 3 set up for us. Okay, so problem 3. It says your rock band has 9 songs recorded, but you only want to put 5 of them on your demo CD to hand out to a local radio station. How many possible ways could the 5 songs be ordered on your CD demo? All right, so is this again permutation or combination? Okay, is order important? And the order is important, so it's a combination problem. So you have 9 songs, you're selecting 5. So 9 objects taken 5 at a time. All right, or fundamental counting principle, if you're going to put 5 songs on a demo CD, 1, 2, 3, 4, 5 different songs, you have 9 options for the first song, then you have 8 options for the second song, then 7, then 6, then 5. All right, so you'll get the same answer if you use a fundamental counting principle or if you use permutations, and I'll show both on my calculator. Oh, by the way, factorial as well. 9, oh, nope, I'm not going to talk about factorial, sorry, not yet. All right, so nine objects, sorry for the glare, 9 objects taken 5 at a time. You should have 15,120, or just using the fundamental counting principle, 9 times 8 times 7 times 6 times 5. You get the same number, 15,120. 15,120. Okay. Let me get the next one up there. Oh, I need some spray. All right. For problem number 4, it says a witness at the scene of a hit-and-run accident saw that the car that caused the accident had a license plate with only the letters I, R, L, T, O, and A. Find the probability. So probability again is favorable over total. Okay. Find the probability that the license plate starts with a T and ends in an R. All right. So we have to think about permutation combination and total outcomes and all that. So since this is a license plate, the order in which the letters are arranged does matter, right? It's going to be a different license plate if the letters are arranged in different ways. So it is a permutation type problem. Okay. Out of those 1, 2, 3, 4, 5, 6 letters, I, R, L, T, O, and A, 6 letters. Out of those 6 letters, we want to choose 2. We want to think about the first letter starting with a T and the last letter starting with an R. Okay, so the easy way of doing this problem, this is number 4. It's a permutation problem with 6 objects. We're choosing 2, taking 2, the first letter and last letter. Okay, so using your calculator, you're going to find that that gives you a total of 30. Okay, 30 different arrangements. So the probability that your license plate starts with a T and ends with an R is equal to, there's only going to be one license plate that starts with a T and ends with an R, so 1 favorable over the 30 total possible. Okay, that's the fast, easy way. I'll explain it showing a little bit more detail in case that's a little confusing to you. All right, so total possible outcomes for the license plate, right? If we have 6 objects taken 6 at a time, so how many different license plate possibilities are there with these letters that were given? Again, it's I, R, L, T, and O. That would be a total of 720 different license plates that it could be with those letters in different arrangements. All right, now I'm going to write not T and R. Okay, so what I mean by that is not using the letters T and R, how many different license plates are there? So if we eliminate the T and the R, we're eliminating 2 out of the 6. So now I have 4 total letters to pick from, and I'm going to choose 4. Okay, so 4P4, and that's going to give you 24. All right, so now these numbers are important for the probability part. So still setting up the same probability problem, the probability that it starts with a T and ends with an R is going to be 24 over 720. Which simplifies down to 1/30th, which is the same answer I got above. Okay, so two different ways of looking at that problem. Let's look at the last problem for today.
Today is Wednesday, April 1st, 2020.
Oh, there's my Alexa. All right, so problem number 5. It says, how many possible combinations, so it's already telling you it's a combination type problem, how many possible combinations of 3 colors can be chosen from the 7 colors of the rainbow, okay? So 7 total objects, 7 colors in the rainbow. We're going to choose 3 because that's what the problem tells us to do. So you're just plugging this into your calculator. You could use the formula. Remember, it's going to be 7 factorial over 7 minus 3 factorial times 3 factorial. Okay, if you want to simplify, 7 factorial over, simplify inside the parentheses first to get 4 factorial times 3 factorial. That's 7 times 6 times 5 times 4. I'm going to stop at 4 factorial so that it can cancel with the 4 factorial on the bottom. So I have 7 times 6 times 5 over 3 times 2 times 1, which is going to give you 35. Now I am going to show that on the calculator, but I just wanted to review how to simplify it longhand as well. So with your calculator, again, hit math, go over to prob, but now you're going to go down to option 3 because it's a combination type problem. 7 objects, choosing 3. And you get a total of 35. Okay. That is it for the last bit of lesson 10.5. So jump on over to our online textbook and do the homework assignment. See you guys tomorrow. Bye.